Welcome to the final review video for this year. So this is going to cover questions 57 to 94. So we'll just jump right in, starting with identifying the types of segments we have. So for tangent line only touches in one spot, so that'd be this one right here. Actually, use the highlighter. And so that, to name it, because we have points, would be UV. And you put the little arrows because it's a line. And then your point of tangency is where does it touch the circle? Well, this line touches at U, so you just put U. For chords, you have a couple options. You have, I'm going to erase this so that we can understand, but you have RQ because its endpoints are in the line, or you also have ST. But notice both of those are line segments. So we have RQ, ST, boop. Now, for secant is also ST, but it's going to be this entire line. So when we write it, we write ST with the little arrows on the top. For radius, we have three. We have RP, PQ, and UP. Ooh, can't write. Okay, and then for diameter, our only diameter that we have for this is going to be RQ. Boop. All right, so what in the world? Making stuff happen. We'll just move that back as if nothing ever actually happened. All right, so let's see if my screen will behave. So identifying radius and point of tangency and equation of tangent line. For radius of D, we start at our center point D and we count 1, 2, 3, 4. So our radius is 4. Then for E, we count from E, 1, 2. Our point of tangency is going to be where these circles intersect. So it's going to be this point right here, which my X value is 0. And my Y value is 1, 2, 3, -4. Okay. And then the equation of our tangent line, since it touches the Y-axis, it's going to be Y equals, and then it's Y equals -4 because it should be the same as that number. Okay, so those numbers should always be the same. If it was X equals, then it'd be X equals 0 because it's the same as the point of tangency. So for 59, radius of M, we're looking at circle M, it's just one little radius. For circle N, we have 1, 2, 3. I'm going to get rid of these little markings so it's not distracting. Point of tangency is going to be right here, so that's X value -2, Y value also -2. And then our equation of the tangent, because it's touching the X-axis, is X equals -2. All right, and for you OCD people, I'm sorry I didn't switch back to green. But continuing on, for 60 and 61, because these are both tangent lines and they meet at a point, we know that these segments are going to be congruent to each other. So we just set to them equal and solve. So 3x minus 1.2 equals 2x plus 1.8. So we would combine our like terms, so minus 2x on both sides. That gives me x minus 1.2 equals 1.8. And then because that's a negative 1.2, I'm going to add. That way that becomes 0. And 1.8 plus 1.2 is going to be 3. So now that I know that x is 3, because I want EF, I'm going to plug into this one. Technically, you could plug it into either of them and still get the same answer, but I have a tendency just to plug it into the one they want me to unless it's really ugly. So 3 times 3 minus 1.2. 3 times 3 is 9. Minus 1.2 is 7.8. Probably should have been able to do that in my head, but oh well. So 7.8 units. So then for 61, exact same process. We're going to have set them equal so that 5x equals x squared divided by 2. Now remember that little magic trick. To get rid of this fraction on the right, because it's divided by 2, we're going to multiply by 2 to both sides, because then that just goes away, and we have 10x equals x squared. So then, because I have an x squared and an x, I want to get them all to one side because this is a quadratic, and I'm probably going to have to factor in some way, shape, or form. So 10x minus 10x is 0. That's totally fine. Don't be scared of it. And x squared minus 10x. Oops. Boop. So then, on the right, because we have x squared and 10x, they both have an x in common, so I can take out x because it is the greatest common factor. And then it's like you're undistributing. X times something gives me x squared, and that's going to be x times x. And then x times negative 10 would give me negative 10x. And you can just check it real quick. X times x is x squared. X times negative 10 is 10x. So we did it right. Go us. Get rid of the extra highlights though. So then, I know you wish you were done, but not quite. You take each of these factors. So you'll take this one and this one and set them each equal to 0. So I'm just going to do it underneath x equals 0. X minus 10 equals 0. So for this one on the left, I can't do anything to it. And because I'm finding a measurement, if I were to plug in 0, it wouldn't make sense. So I'm just going to ignore that one. With this one, I'm going to add 10 to both sides, and that gives me x equals 10. Well, that's a number I can plug in. So this is one of the times where even though they want EF, and even though technically you should plug into the x squared over 2, these things are equal. And it's much, much easier to just plug into 5x. 5 times 10 is 50. Boop. Now, let's say you don't believe me and you just think I'm crazy, which is possible. Then plug it into the other one. If you did, you'd have 10 squared divided by 2. 10 squared is 100 divided by 2, which is 50. So see, they're the same. All right, so moving on. These circle graphs shows data collected by the U.S. Census Bureau in 2004 on the highest completed educational level for people 25 and older. Use the graph to find each of the following and then round to the nearest tenth if necessary. So for this, we're just going to start with 62, measure of angle CAB. So remember, you just follow the letters C to A to B. And so that little section is 32% of this circle. So that would be 360 degrees in a circle times 0.32, because that is the percent as a decimal. So 360 times 0.32 gives us 115.2 degrees. Okay. For the measure of DAG, I'd go D to A to G. So I notice that includes this one, and this one. So I'm just going to add all those up. 1% plus 7% is 8%. 8% plus 18 is 26%. So 360 times 0.26 is 93.6 degrees. So then, measure of EAC, we go from E to A to C. So E, oops, I wanted the highlighter for that one. E to A to C, that is 18% and 17%. So 18 plus 17 is 35. So as a decimal, that'd be 0.35. So 360 times 0.35. Oops, 0.35, can't type on my calculator, is 126 degrees. Okay. For the next one, we want the measure of arc BG. So from B to G, it is the arc. Notice that takes care of this 25%. So then we would have 360 times 0.25, which is 90 degrees. And I realize I should probably highlight these. There we go. All right. For GF, that's G to F. It's literally just the doctoral slice, so that's 1%. So that is 360 times 0.01, which My mental math is telling me it's 3.6, but I just don't trust myself sometimes. So that'd be 3.6 degrees. And then BDE goes from B all the way around to D, all the way to E. So that is 18%, 17%, and 32%. So when you add all of those up, it is 0.67. So 360 times 0.67. Oops. Time to type on my calculator. Is 241.2 degrees. All right. So with this chart, you do not have to fill it in because we did do it during notes. But if you do want to fill it in real quick, I'm just going to do it probably really fast. So first off, vertex of an angle, if it is in the center, and this is on your formula sheet, by the way, if you feel like you're not going to remember these rules, you have them on the final. But if the vertex is at the center, that'd be something like this. Let's say this is 50 degrees. It's going to be the same as the arc. So that means measure of angle 1, in this case, would be 50 degrees because it's the same as that arc. If it is on the circle, so the vertex is somewhere on the edge of the circle, doesn't matter where the angle itself goes in the circle, and the vertex just needs to be on it, then your angle is going to be half of your arc. There. So if I had, let's say this was 60 degrees now, if that angle 1 opened up to a 60, then the measure of angle 1 would be 30 degrees because it's 60 divided by 2. Okay? If your vertex is inside the circle, so something like, let's say that, and I'm just going to make up some numbers. We're going to say this one's 40 degrees and this one's 100 degrees, which this is not going to be proportional whatsoever, but that's okay. But then it is going to be the sum of your arcs, of intercepted arcs, that's important, divided by 2. So what that means for you is if we're talking about angle 1, measure of angle 1 would be 40 plus 100 because those are the two arcs, divided by 2. 100 plus 40 is 140, so that divided by 2 is 70 degrees. So then both 1 and that one over there would be 70 degrees. The last case we have is if it's outside the circle, and it's super similar to the one we just did. But in this case, I'm going to say this is 20, and we're going to say this one's 120, make my life easy. But it would be the difference of your arcs divided by 2. So in this case, if I want the measure of angle 1, I would do 120 minus 20 divided by 2. So then that would be 100 divided by 2, which is just 50 degrees. So for 68, we're going to have to use a variety of these things. So if I want QS, that's going to be this one right here. So I know I need to find these angles. So first, to find this angle, I notice that I have a straight line right here. And since I have a straight line, I know that this angle plus this angle plus this angle should be 180. So 180 minus 55 minus 47 gives me 78 degrees. And then, for the sake of just getting all of the angles, if I wanted this angle next to it, so right here, again, I have a straight line, so I know that this one and this one and this one will add up to 180. So 180, minus 78 minus 55 is 47 degrees. And so then, to find your last one, you can either subtract them all from 360, or if you use this purple line as your line again, you know that this one and this one will add up to 180. So 180 minus 47 is 133. So now that I have all of them, it's going to be slightly easier to do the measure of the arcs and stuff. And I'm going to get rid of my random little lines here. So if I want QS, these are central angles, which you can see because of that P, point P. So that means that my arc is going to be the same. So QS is going to be 47 plus 78, which is 125 degrees. And then for RQT, we go from R to Q all the way around to T. It is going to be 47 plus 133 plus 47. So 47 plus 47 plus 133 is 227 degrees. Okay. For 69, if we want HG, that's going to be this little slice right here. So again, I have a straight line right here, so I know it'll add up to 180. So 180 minus 23 minus 90, because remember, that's what that little symbol means, is 67 degrees. So if I just want HG, then I know it's going to be the same, so it's 67 degrees. Then I want FEH, so F to E all the way around to H. Because I have this straight line, I know this is a diameter, so this is 180 degrees. So for FEH, I would have 180 plus 23, which is 203 degrees. Okay. For number 70, we have that circle L is congruent to circle E, which is ironic because that should be circle B. Just now noticed that. And CBD is congruent to angle FEG. So what that means is we have congruent angles, which means these chords are also congruent. So I'm going to take these two values and set them equal to each other. X squared equals 7x. Again, we have an x squared with an x, so this is a quadratic that will probably need to be factored. So we're going to move everything to one side. That's 0 equals x squared minus 7x. We have an x in common, so we can factor one out. And then x times x gives me x squared. X times negative 7 gives me negative 7x. So again, you should just be undistributing, so double check it by distributing. So then I have these factors, so I will set each of them equal to 0. This one with x equals 0, I can just ignore because it's a length. So I'm going to add 7 for this one, and we get x equals 7. So then to find FG, we just plug it in. 7 squared is 49. If you didn't like that one, maybe you wanted to plug it into that 7 times x. 7 times 7 is also 49. So regardless of what you do, you still get the same answer. Why does the highlight keep moving with it? It makes no sense. There it goes. All right, so for 71 and 72, you are going to make your own little right triangle. First off, we know that the radius of this circle is 40 because it's 12 plus 28. So then what I can do is I can draw in a little baby right triangle right here. And what happens is that the length from WY is 40 because it's the radius. So now I have a right triangle that I know two sides, and I need to find my third side. And I'm just going to label it as B. So that would be Pythagorean theorem. So 12 squared plus B squared equals 40 squared. That would be 144 plus B squared equals 1600. And then when we subtract 144, we get that B squared equals 1,456. And then we take the square root of our answer. And we get that B is approximately 38.1576. And I'm just going out a few extra decimal places just for fun. So notice that is just going to be this length. I also need this length right here because I want the full thing. So the theorem for this says that with this little right angle right here, we know that this is bisected so that these sides are congruent to each other. So we multiply this by 2 so that we can get our full answer. So that gives us 76.32. And since we're rounding to the nearest tenth, it would just be 76.3 miles. Okay. So for 72, it'll be the exact same process. Our radius for this one is going to be 4 plus 0.7, so that'd be 4.7. So we draw in our right triangle right there. Oops. And we know that ED is 4.7. And then we're looking for B, which is that little short side. Again, we're going to be multiplying by 2, but for now, we're just going to set this up. 4 squared plus B squared equals 4.7 squared. So then that would be 16 plus B squared equals 4.7 times itself is 22.09. So when we subtract 16, we get that B squared is 6.09. And when we take that square root, it gives us 2.468. So then, again, we are multiplying it by 2 because these two segments are congruent to each other, and we need the full length. So that would be 4.94. Again, nearest tenth would just be 4.9 kilometers, and my number looks funny, so I'm just going to fix it. Okay. All right, so for 73, usually with my finger it doesn't. Keep drawing, okay. Special technology. All right, so for 73 and 74, you have formulas for on your formula sheet. But because we want area of the sector in terms of pi and round to the nearest hundredth, our formula, because it's area, is going to be the area formula of a circle, so pi r squared, times the percentage or fraction of the circle we are looking at. So that's going to be based on the degree measure. So we have pi. Our radius in this case is 18. And then my degree measure is going to be that 140. So 18 squared times 140 divided by 360 gives us 126 pi. So that's going to be one of my answers, and that'd be millimeters squared. Or if we multiply the pi in, would be 395 point nearest hundredth 84. Ooh. Okay. All right. So 74, the speedometer needle of Ignacio's car is 3 inches long. The needle sweeps out a 130-degree sector during acceleration from 0 to 60 miles an hour. Find the area of this sector, and then give your answers in terms of pi and round to the nearest hundredth. So if you think about a speedometer, even though it's not a full circle, they are just telling us that this speedometer goes from 0 degrees all the way to 130 degrees. So because it's 130 degrees, we know that it's both the angle and the arc. And then they tell us that it's 3 inches long, so that is our radius. So exact same formula as before, pi r squared times your measure of your angle or arc divided by 360. So that'd be pi times 3 squared times 130 divided by 360. So 3 squared times 130 divided by 360 is 3.25 pi. So then if I were to actually multiply pi in, 3.25 times pi is 10.21. Okay. Woohoo, almost there. Kind of. All right, so for the next two, we have, again, a formula for this. This is length. So it is going to be the circumference formula, 2 pi r, times the fraction of the entire circle. So since we are doing length, my radius is 4, so 2 times pi times 4 times 60 over 360. So then when we multiply, 2 times 4 times 60 divided by 360 is 1.33 pi. Ooh. Okay, and then when we multiply pi in, that gives us 4.19. Oopsie. 9 looks funny. 9 feet squared. So then if I want length again with this one, it's going to be 2 times pi times our radius times the degrees, so it's that 140 divided by 360. So then 2 times 18 times 140 divided by 360 is 14 pi. Oh, and I just realized these are not squared. And then when you multiply the pi in, you get 43.98 meters. So for 77, the length of the arc with measure 45 and a circle and radius 2. Again, we are finding length, so it's going to be the exact same formula, 2 pi r times the fraction of the circle. So that's going to be 2 times pi times our radius 2 times our degrees. In this case, we just want terms of pi, so 2 times 45 divided by 360 gives us 0.5 pi. And in miles. Okay. Oopsie. All right, so 78, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. If inscribed angles of a circle intercept the same arc or are subtended by the same arc, then the angles are congruent. The measure of an inscribed angle is half the measure of its intercepted arc. So that's like those ones. This was 100, this one would be 50. And then an inscribed angle subtends a semicircle if and only if the angle is a 90-degree angle or a right angle. And that is because it's going to be half of 180 degrees. So for 82, to find the measure of BAC, that is this angle right here. It is on the circle, so it's half of the arc. So 60 divided by 2 is 30 degrees. For FE, it's going to be double your angle. So 70 times 2 is 140 degrees. Oopsie. So then for 83 and 84, they are inscribed angles with a semicircle. So because that's a semicircle divided by 2, I know this is a right angle. So then we're just solving 6x equals 90 because it's a right angle. And 90 divided by 6 is 15. So x is 15. So then for this one, same exact thing. It opens up to a semicircle, so that's a 90-degree angle. So we just have to solve an equation. 4z minus 10 equals 90. We add 10, so we have 4z equals 100. And then we divide by 4 to get that z is 25. All right. So then for 85, see, it's coming with me again. I don't know why. The inscribed angles opposites are supplementary. So this one plus this one will equal 180. And I can't do it with Q and S yet because I don't have anything for Q. But I can use T and R to help me. So 3x plus 5 plus 5x plus 15 equals 180. So combining like terms, 3x plus 5x is 8x. 5 plus 15 is 20. So then we would subtract 20. And we would have 8x equals 160. And when we divide by 8, we get 160 divided by 8 is 20. So then, now that we know that x is 20, we can just go in and plug this in everywhere. So starting with t, that would be 3 times 20 plus 5. And 3 times 20 plus 5 is 65 degrees. And again, just make sure you're talking about the right angle. This is angle T, so we are good. So then angle S would be this one in the circle. So 4 times 20 plus 30. 4 times 20 is 80, plus 30 is 110 degrees. So then R is supplementary with T, but I'm going to plug it in just to make sure that my 20 is actually right. So 5 times 20 plus 15 is 115 degrees. And then to double check myself, just subtract from 180, and it should be the same as T, which it is, so we are good. So then for angle Q, that's going to be 180 minus 110, because it's supplementary with S. So then angle Q is 70 degrees. Okay. So then, almost there, we're getting there. For 86, we need to find the measure of RPS. So RPS is this one right here. So because this is inside, I need the sum of these. Notice this kind of looks like a weird plus sign, so that's kind of one way you can remember to add. So I'm just going to label it as P. So P is going to be the sum, 59 plus 201 divided by 2. So that would be 260 divided by 2, which gives us 130. Okay. So then for 87, we want y, u, x, so y to u to x. So we want this angle. So if you do it the same way we did 86 with these measurements, you're going to be finding this angle and this angle, which you can do because then they are supplementary to the one we're trying to find. Or you can subtract the arcs you're given from 360. So I'll show you both ways. Method number one is like the first one. So that would be, let's see, I'm going to label it as VUY because that would be the angle we would get, would be 68 plus 94 divided by 2. 68 plus 94 is 162, and then divided by 2 is 81. So I know that this angle, oopsie, or both of these angles are 81 degrees. So if I wanted to use this method, I would then just do 180 minus 81 to get 99 degrees for this angle. Now, some of you are probably thinking that's too much. I don't like that way. If you don't like that way, then your alternative is to option B, is to subtract the ones you are given from 360. So 360 minus 68 minus 94 gives us 198. And then this is the sum of VW, the arc, and XY, the arc. So then you would just divide that sum by 2. And again, you get 99 degrees. So it does not matter which method you use. Both methods obviously work, but whatever one you are most comfortable with. So for 88, we want to find the value of x. Since it is outside, we are going to subtract these two arcs. So x equals 173 minus 79 divided by 2. So that would be 94 divided by 2, which is 47 degrees. For 89, I'm going to have to subtract again, but I notice that I only have given one arc. So to get this arc measurement right here, you would do 360 minus 116, and that gives you 244 degrees. So then you're going to be subtracting these two arc measurements, 244 and 116. So x equals 244 minus 116 divided by 2. 244 minus 116 is 128, and divided by 2 is 64 degrees. All right, so then for number 90, here it goes again, being silly. Go away. Oh my goodness. So for 90, I'm assuming that this 56 is the arc measurement. So taking that into assumption, I can find this arc, KM, by doing 360 minus 187 minus 56. And so that would give you 56, not 36, 117 degrees. And this is helpful because we want to find JKM, and JKM is this angle right here. So because the arc is 117, I'm going to do 117 divided by 2 because this angle is on the circle. And 117 divided by 2 gives us 58.5. So 58.5 degrees. All right, so last but not least, we have our circles. So you are given the equation of a circle on your formula sheet. But if my circle is centered at the origin, I know, and I'm just going to write the formula so I have something to refer to. So since it's centered at the origin, in this case, I know that h would be 0 and k would be 0. So that would mean my formula would be x squared plus y squared equals r squared, and my radius is 10, so r squared is 100. So it's going to be equal to 100. For 92, it's centered at the origin again, and it passes through 9, negative 2. So since it passes through 9, negative 2, you know that that's going to help you find your radius. So my radius is going to be the distance formula. So square root of the x is subtracted, so 0 minus 9 squared, plus the y is subtracted, 0 minus negative 2 squared. Keep in mind that minus a negative 2 becomes a big fat positive. So then you have, and I'm going to change colors again, that your radius is the square root of 9 squared plus 2 squared. And I know that technically that's a negative 9. Doesn't really change anything. So then this becomes the square root of 81 plus 4, which is the square root of 85. So again, this is the radius. So if I want my radius squared, is going to be the square root of 85 squared. But when you square a radical, you just make the radical disappear basically. So then my r squared is just 85. So then to plug it into the formula, again, it's centered at the origin. So I don't have anything for h, so it's going to be x squared. I don't have anything for k, so it's going to be y squared. And then it's going to be equal to the radius squared, which we just found was 85. And then you're done. So then for 93, we have a center at 11,4, and it passes through negative 2, 5. So writing the formula, I know I'm going to have to solve for the radius, but I would rather just get part of the formula down first. So I have an x value for this one. It's 11. So in my formula, it needs to be the opposite sign. So even though it's a positive 11, it's going to be x minus 11 squared. Then we have our y value, so y, and then it needs to be the opposite of this number again, so y minus 4 squared equals our radius squared. And our radius squared we have to solve for. Now, the bonus to doing this is if you use the circle formula that you started, that's going to be equal to r squared, and that number is going to go away here soon. But since this equals r squared, what we can do is plug this into the formula we already have. So the x value we have is negative 2, so negative 2 minus 11 squared, plus the y value we have was 5, so 5 minus 4 squared, and that's going to be equal to r squared. So we'll fill that in once we solve all this. So then negative 2 minus 11 is negative 13. So negative 13 squared. 5 minus 4 is 1, so that's just going to be 1 squared equals r squared. 13 squared is 169, plus 1 squared, which is just 1, is 170. So the advantage to doing it this way rather than using the distance formula is that now you already have your r squared and you don't have to deal with that squaring a square root. So then our radius squared is 170, so this is equal to 170. Okay, oops, went too high. And now it's laggy. There it goes. Boop, 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 boop. Okay, so then, last but not least, 94, the final question on the review. Our center, again, is going to be opposite numbers. So my x value, even though it says minus 1, is positive 1. And then my y value, even though it says negative 1, is another positive 1. And then my radius is the square root of whatever number's here. So square root of 16, which is 4. So then to plot this, we just go to 1, 1. So right 1, up 1. That is our center. And then our radius is 4, so you just count to the right 4. 1, 2, 3, 4. You count up 4 from the center. 1, 2, 3, 4. Left 4 from the center. 1, 2, 3, 4. And down 4 from the center. And then, to the best of your ability, just try and make it look like a circle, which I'm surprised that one turned out as well as it did. So that is the end of your semester review. Go you, make sure you study for the test, and make sure if you're still kind of lost, you watch the video for the practice review or the practice final or any other videos really that have been made, because you can do this. I promise. You got this.